Okay, welcome to this video on 6.6b. That's algebra, quadratic word problems. Okay, so what's going on here is we're trying to solve equations related to motion by simply plugging in a couple of different variables and then using what we already know. We used to have this bubble in this class. It was basically to set the right side of the equation to 0, to factor the left side of the equation, set the factors to 0, and solve. So make sure you have today's date here, where whatever it may be, today's date. At this recording, it's the 28th of May. So let's think about this problem for a second. We've got an object that's launched upward at 64 feet per second. I just want to draw your attention. This is the velocity that it's thrown up at, and they put it into the equation for you. So they put it in for you. And they wanted you to know that it's 192 feet. So your starting point, your S, your starting point is 192 feet. They put that into the equation for you as well. And that negative 16 represents half of gravity. Okay, so half of gravity. So we want to just figure out when the object strikes the ground. So when an object is striking the ground, that's going to be our final height, striking the ground, h, which is your final height. And what would the final height be if it's hitting the ground? How high up is the ground? You're outside walking on the ground, okay? And let's say you're walking on a nice flat field, and your friend is up in the bleachers, and one of your other friends is hanging out playing and down inside of a manhole. Okay? Well, what height are you at? 0, right? So let's just assume that ground level is 0. Let's not get too intense with like sea level. We're just saying ground level. So ground level versus sea level. And ground level is 0. So the final height is 0. So we want to set our final height to 0. We have to assume for these mathematical problems that we're on a flat surface playing field. Okay, so we have to assume that, or else we'll have some big trouble in getting all of the equations, calculations right. So we want to keep it pretty simple. So I'm just going to say that the final height, which is actually, shouldn't really be S of t. In our notes, we've been putting this as h. So if you want to change that to h, that's fine. So height is equal to negative 16t squared plus 64t plus 192. So I would encourage you to, where you are, just pause the video and try to solve that equation for time. Try to find the times that will satisfy that equation. Try to factor it, set it to 0, and so forth. So pause the video and give that a try. Now, if you're trying to solve the problem and you don't really know where to start, I put up some of the rules that we use to solve quadratic equations. So the rules are right here. Set the right side to 0, factor the left side, set each factor to 0, and then solve the equations from step 3. So what you want to do is just try to follow those steps to get this thing done. Okay? Now, obviously, you don't have to set the right side equal to 0. You could just put this 0 over here. So what I'm going to do is I'm going to erase this, and I'm going to say, okay, well, now the right side's equal to 0. So let's say step 1 is done, and then you just need to do step 2, step 3, and step 4. So pause the video again and try that. I'll see you in just a moment. All right, so hopefully that went well for you. Make sure if you haven't finished to just pause and try this problem. And I'm going to go on and try one that's a little bit trickier. Hopefully you found that one to be not too bad. This is a pretty fun problem. I like this one. It gives you the equation height equals negative 16t squared plus v times t, velocity, plus s, which is starting point. So I'm just going to kind of quickly, this is the starting point, this is the final height. And I want to look at these things, okay? And I know that everything that I'm doing is in feet per second. So it says Nolan Ryan, who's a baseball pitcher, throws a ball straight up at about 90 miles an hour, which is also, aka, 128 feet per second. So we know that, like, if all of this is in feet, this 90 miles per hour is kind of a distractor. It's there for people that play baseball so they have an understanding of how fast he threw it. But really, it's 128 feet per second that we want. Is the 128 feet per second the velocity, the starting point, or the final height? velocity, because it's how fast it's going, right? Velocity is how fast. So this is v, which is velocity. Now, did he throw it up or down? Up. So I'm going to say that it's positive 128. I'm going to put a plus there. So I'm going to go ahead and think about that for a second, and now I'm going to keep going. This stadium doesn't exist anymore, the Metronome. Used to be in Minneapolis, Minnesota. We know the stadium ceiling is 192. We want to know when the ball will hit the ceiling. Is 192 the final height where we want to know, or is that where the ball started? 192 is the final height, right? So we know that the final height, h, which is final height, is 192, and that's up in the air, so I'm going to say plus. It's not dug 192 feet underground. And now the question is, do we know where Nolan Ryan starts? Where does Nolan Ryan start?
0.
Very good. The starting point of Nolan Ryan, S, is equal to 0 because he is on the ground. So I use green. Yeah, we're just going to simplify a little bit. You're right, but we're just going to simplify it a little bit. Later, it will be a little more complicated, but we're going to say that Nolan Ryan is, he brings his hand all the way down to the ground, okay, like that, to throw the ball up. So here's the ground, and that's how he decided to do it, okay? So you get the gist. It's just to simplify the problem a little bit to kind of help your life, okay? So trust me, you want me to make your life better when it's possible. Now I'm going to draw in the Metronome, and because it's in Minneapolis, Minnesota, which is like the Vikings territory, we'll make it purple. So this is the Metronome. Now it's not to scale, guys. He's not actually that big, but just let it be, okay? So he throws the ball up, and we know that he throws it up, and it gets to a height of 192. This is 192 right here. So 192. So let's think about the equation that we're going to have. I'm going to split the screen, and I'm going to fill in this equation with everything that I know. Everything I know I'm going to put into this equation. So let's try it out. Well, the first thing that I know is that his final height is going to be 192. So I'm going to fill that in with 192. I'm going to fill that in with 192. So 192 equals... This is negative 16t squared plus the velocity, which we said over here was 128t, plus the starting point, which we said was 0 because he was on the ground. So that's the equation we need to solve. Once you've plugged in those things and you understand the drawing and you know what's going on here, now it's pretty simple. You just solve. So I'm going to block out everything except for the equation, so we can just focus on the equation. We pretend it's a worksheet now instead of a word problem. So set the right side to 0. So if I move this over to that side, minus 192, minus 192, I have the following. I have negative 16t squared plus 128t minus 192 equals 0. Think about how you can solve that equation. Is there a greatest common factor? Can we pull something out? So look at the problem and see if you can divide by something. Any ideas? What might we be able to divide by? Well, I could take 128 and try to divide it by 16 or 8 or 4, because I know those are numbers that might work. So I'm going to take 128 and I'll try to divide it by 16. It goes in 8 times, which is really nice. So I'll take 192 and I'll try to divide that by 16. It goes in 12 times. So it looks like 8 goes into this one. It goes into this one 8 times, and it goes into this one 12 times. So let's think about that for a second. So I pull out negative 16. A negative times a what will be a positive? A negative times a negative, it's going to be negative 8t. A negative times a positive will be a negative, and that's 12. So that's the first step. If you want to clean the equation up, you can clean it up by dividing the negative 16, right? You don't really need that. So you could divide both sides by negative 16, make it look a lot nicer. It's a lot less stressful when you look at an equation that looks like just this. T squared minus 8t plus 12 equals 0. That's a nicer looking equation. That's something we could solve pretty well. So I'm going to ask you to think about that. Maybe you could even pause the video and try to factor that yourself and come up with a couple of times. I'm going to go ahead and work it out as well, but you can try it at home as well on your own. Okay, so you'll notice that I've solved the equation and I got two different times, 6 and 2. It's either going to take the ball 6 seconds to get to the ceiling or 2 seconds. So now we need to look back at the picture and say to ourselves, does it make more sense for this to take 6 seconds or 2 seconds for it to hit the roof of the Metrodome? So it's either t equals 2 seconds or 6 seconds. What are our thoughts on that as you think about this problem? What do you think? Did it take 2 seconds or 6 seconds? Yes. 2 seconds. So it took 2 seconds to hit there. And then what happens? Does it ever go up further than that? Does it ever get to go way up into the atmosphere and then come back down? It doesn't get to because the ceiling stops it. As soon as it hits the ceiling, it goes straight back down, boom, like that, and hits the ground. But in a mathematical realm, this would be time 2. And this would be time what? 6, right? And when would the ball make it to its exact highest point? Exactly at 4 seconds. So it'd take 4 seconds for the ball right here. This would be t equals 4 times 4 for the ball to be at its maximum height. No, you can't really, but that's because we have 2 and 6, right? And what's right in between 2 and 6, right? It's never going to happen because it's not going to punch through the ceiling of the Metrodome, right? But I'm just looking at mathematically if we didn't have that ceiling there to slow us down, right? So it's going to go all the way up. It's going to stop at 4 seconds if there was no ceiling there. It's going to fall back here to 6 seconds. What time do you think it's going to be here if you had to have an idea? Time equals 8, exactly. That'd be time equals 8. And this would be time 0, right? Time equals 0. So this is what would happen, but how much of this never happens? A whole lot of it. None of this ever gets to happen because what happens to the ball? It hits the ceiling and drops right back down. So none of this is real. But in the math problem, it's all real, agree? All those numbers are going to matter. They're going to come up. But in this problem, we know that it takes 2 seconds for the ball to hit the ceiling. So that's how we use a little bit of our brains, our logic, to be smarter than just a calculator. So hopefully that problem made sense. I want you to pause the video and try this problem here, which is number 3. And I want you to do that as a now you try. So pause the video and give this one a try. Now you try number 3. Now if you're not really sure how to start this problem, I would recommend you putting S, which is the starting point, right? Starting point. I would just write S equals. And then I would write V equals, which is the initial velocity, or just velocity. Initial velocity. Initial means at the beginning, right? Initial velocity. And then H is your final height. H, which is your final height, the height in the end. And write down what that is, okay? So take a second and think about what your starting point is. Where did the ball start? How fast was the ball going when this thing was thrown or whatever? And then what was the final height? Where did it wind up in the end when it came to rest? So as you're solving this problem and you've paused the video and you've tried it, I'm going to tell you the answers. I'm not going to give you all the work, but I'm going to tell you that you come up with 2 answers. You get an answer that's t equals 1, time is 1, and then t equals 7 seconds. So one of these is when the ball lands on the school. So why don't we draw a little diagram to get a gist of what's going on here. It's either 1 second or it's 7 seconds. So here's school, okay? S-C-H-O-O-L, there we go. Has a little flag on it, maybe. There we go, cool. So we know the ball is launched up from ground level. We got this person down here at ground level, and they throw the ball. And it comes up like this, and then it lands on the school. So what do you think is happening? This is the height of the school, agree? So how long do you think it takes to get to that height? This is a height equals 112. What time do you think this is? T equals. And what time do you think this is? T equals. Thoughts? T equals, on the first one, I think it's 1 second. T equals 1 second. Agree? And then by the time it goes all the way up and comes back down and lands on the school, it's T equals 7. T equals 7. So 7 seconds is the answer. 7 seconds. Okay? So we're kind of running out of time here. I was planning to do this problem for you. I will at least show you what we're trying to do. We're trying to find h when t is 3. So I want to plug in 3 there, and I want to plug in 3 there as well. This is 3 seconds after we threw it, and then we want to figure out that answer. That's where the object will be, how high up it will be. And then they want to have you tell you where the object is going to, when the object is going to strike the ground. So the object is going to strike the ground when the height is equal to 0. So I'm going to put the height on the opposite side, and I'm going to set this equal to 0. Then you want to solve that, and that'll tell you when the object strikes the ground. So that's pretty much the end of this video. We're going to wrap it up. I will see you in the next video. Peace.